Hello everybody, welcome back. This is lesson 4 in unit 3B, and today's lesson is called polyatomic ions. So in the last video we talked about naming molecular compounds, or again molecular is the same, we see molecular, you mean covalent compounds. So that's one of my personal favorite naming lessons. But today we're going to talk about polyatomic ions, what they are, how they're formed, how to name them, how to write the formulas. So bunch of info about to come at you. So polyatomic ions are essentially groups of atoms that are covalently bonded together, but with an overall positive or negative charge. So here we have ammonium, and you have these shared electrons, so those are your covalent bonds, but we have this positive charge. And now remember, compounds should have this overall neutral charge. So this polyatomic ion on its own has to be combined with something. So polyatomic ions will then ionically bond to another ion, another polyatomic ion. And so the most important thing is right here. Any compound with a polyatomic ion has both ionic and covalent bonds. And so we'll go through a few questions like that because that is one of the most popular questions on this topic. So when we're dealing with polyatomic ions, you have to treat them as its own thing. So think of it like Legos glued together. It's obviously made of different pieces, but those glued Legos, you're not separating them. They travel as a unit. So here we have, this is phosphate, and it has that -3 charge. So on its own, not okay. Our compound has to have a overall neutral charge. But here we can see, these shared electrons, this covalent bond. But here we also have 3 sodium ions. So this triple bond is your ionic. So you have ionic bonds, you have covalent bonds. And if you have 3 positive ones, you cancel out the -3, so your overall compound again is now 0. So at this level in Regents chemistry, you do not need to memorize the polyatomic ions, their names or their charges. If you do move on to AP Chem, that is like summer homework before you even start, is memorizing this stuff. But Table E is a super, super useful tool. Remember that it is there. You don't need to guess about polyatomic ions. It is literally right there in front of you, if you look. So here's one of the questions I had mentioned briefly before. Which one of these compounds has both ionic and covalent bonds? So whenever you see both ionic and covalent, you should think, oh, it's a polyatomic ion. We got to think Table E. So in these compounds, you want to find a compound that has something on Table E. So here's an example. So we know NaCl is ionic because it's a metal and a nonmetal only. H2O is just covalent. C6H12O6, all nonmetals, it is covalent. But if we look at this one, ClO2 is right here on Table E. So this part right there in that green box has covalent bonds, but that polyatomic ion and Mg are connected ionically. So again, you want to see which one of those compounds has something on Table E. Another good way to look at it is if you have all nonmetals, most of the time, there is an exception if you are dealing with ammonium. But if you have all nonmetals, your good guess would be covalent. If you have a metal and a nonmetal, that is your ionic. If you have a bunch of nonmetals and a metal, that is, so multiple nonmetals, and a metal, that is probably going to be both. So that works sometimes. It really just is easier to just look on Table E. So if you have a compound on Table E, or a part of a compound on Table E, that is both ionic and covalent, because these rules don't always work. So go ahead and try this one on your own. Which one of these compounds has both ionic and covalent bonds? So again, ionic and covalent, you should be thinking polyatomic. You should be thinking table E. So looking at table E, looking at your answer choices, LiOH, OH right here, where is it, is on table E. So therefore, that one would have both ionic and covalent. This is all nonmetals, straight covalent compound, straight covalent bonds. All nonmetals, straight covalent. All nonmetals, straight covalent. So again, checking table E is what you have to do. Okay, so if we have a formula of a polyatomic ion, this is pretty simple. So we have calcium, and again, at this point, should somewhere be in your head, but if not, never guess, always check your periodic table. Calcium has a +2 charge, and now we're going to look at phosphate. Now, I don't remember the formula for phosphate. What am I going to do? I'm going to check table E. So phosphate, where is it? Phosphate is right there. PO4 with a -3 charge. So PO4 with a -3 charge. So what this means is that P and those 4 O's are combined together. Those are those glued Legos. They do not separate. And so as a whole, that's why we have parentheses that has a -3 charge. So when we crisscross, we do just like we did before. We have Ca, but we're going to have 3 of those. And now remember, PO4 travels as a unit, so keep that in parentheses. But now you have 2 of them. So you have 2 of those PO4 things. So 2 of those glued together Legos. And that is it. So what this shows us, that 2, that's the same thing as saying PO4, PO4, that you have 2 of them. But again, that's a lot of writing, so that's why we have that little 2 and those parentheses. The PO4 does not break apart. Okay, so in this compound, we would have 3 CAs, we have 2 phosphoruses, we have 8 oxygens, because again, that 2 gets distributed. Okay, so let's try this one. Lithium is +1. Now chlorite, I don't know what that is. Let's go ahead and check table E. So you want to be very careful because some spellings look very similar. So you have chlorate, chlorite, so be careful with that. But the one that we are dealing with is ClO2 with a -1 charge. Okay. So we're going to crisscross it. 1, 1. And so we get LiClO2. Now, you do have those invisible ones, but remember, you don't need them. Now, if you left it like this, that would be fine. Now, if you only have one of those polyatomic ions, you don't necessarily need the parentheses. So if you just wrote like that, that is also fine. But writing the parentheses around the polyatomic ions do come in handy if you have multiple of them. So let's try this one. What do you think the formula for ammonium nitrate would be? So ammonium, that's no element that we know. Let's check over here. So ammonium is NH4 with a +1 charge. NH4 with a +1 charge. Nitrate is somewhere over here. Again, be careful with the names because you have some ones that are similar, which is NO3 with a -1 charge. So crisscross, you get NH4 with the 1, you get NO3 with the 1. Again, you don't need those ones. And because you only have one of those polyatomic ions, you don't necessarily need the parentheses. So if you wrote it like this, or if you wrote it like this, it's not wrong. You just won't see it in the textbook that way, but totally accurate. A textbook would say NH4 NO3 like that. And so that would be your final compound. Again, if you wrote it like this, or if you wrote it like that, it's not wrong. You just won't see it that way. Okay, so naming polyatomic ions is pretty simple. Naming the cation or the positive part first. If it's an element, you name the element. If it's a polyatomic ion, you use table E and name the polyatomic ion. For the anion, if it's an element, you use the IDE ending, and we've been using that forever. And if it's a polyatomic ion, you use table E. And again, cation comes first, then anion. But you do also want to make sure your compound does have this polyatomic ion. So if we look at NaOH, you should be like, there's three elements. I don't know how to name that. You should probably check table E. So if you check table E, OH is right there and is hydroxide. So if we go back to our list, or directions, element, you name it. The first thing, you name it. So Na is sodium. And then the negative part, if it's a polyatomic ion, you just use its name on table E, which is hydroxide. And that is it. So no prefixes, no nothing, that is it. Okay, so go ahead and try this one. What is the name of KClO3? So you should see, there's a lot of stuff going on here, but ClO3 is right there. So ClO3 is chlorate, like that. And then K, you just name potassium. So potassium chlorate is your final name. So there are some real world examples of polyatomic ions. Calcium carbonate. So carbonate is found in seashells. Sodium hydrogen carbonate, you'll also see it as bicarbonate, is in baking soda. And then hydrogen sulfate, can be found in batteries. So there's a bunch more, but these are some cool examples that you have probably experienced at some point in your life. So that is it for polyatomic ions. If you're still confused, rewatch this video as many times as you need on YouTube. And on the next episode, we will cover bond polarity and bend, and there's a few cool things that we'll do with this. So on that note, have a wonderful day. Bye.